balance. My team is composed by Fabiola, Diana, and me, Dani. Next, please. The first is the pH. What is the pH? Well, the pH is an inverse measure of the concentration of hydrogen ions in a solution. What does inverse mean? What does inverse? What is your idea of the pH? No? Well, it's an algorithm used for relation for the acid and alkaline hydroelectric balance. Okay? Next, please. Well, some examples for a pH scale: hydrochloric acid and sodium hydroxide. A neutral position and level 7 ever is the pure water. That's okay? Okay. Acids and bases. Acids. Acids are sour tasting in the food. For example, the vinegar. Arrhenius acid is any substance that, when dissolved in water, increases the concentration of hydrogen ion. Proton-Lowry acid and proton donor. Well, when in a solution, you mix the acid with water, for example. The acid gives a ion, and this solution is neutral because the ions for the water neutralize the effect of the acids. That's okay? Next to the bases are bitter tasting and slippery. Arrhenius bases are any substance that, when dissolved in water, increase the concentration of hydroxyl ion. Well, in this case, exists the measure of the acidity of the solution for the change of the ions. Next, please. Well, the examples of food and acid and alkaline levels show in this graphic the level neutral ever is the water. In the alkaline exists, for example, many fruits and vegetables. And acidic, it's the processed or fast food. For what is the reason for this process? Ever, all food, when have a process of physical process, ever have acid, and in an impure state is ever alkaline. That's okay? For example, when you cook a fruit for make a dessert, the properties of this fruit change and have acidic properties when they change the physical state. That's okay? The pure state ever is alkaline, and when you make a process, a physical or a chemical process in the food, this food is acidic. In this example, the soda, coffee, donuts, etc. That's okay? Those? Any questions? Next, please. Okay, what is an acid? An acid is a substance which, when dissolved in water, releases protons. It's the change of the ions for the protons for the different electric charge. The extent of dissociation, that is the amount of the proton released and compared to the total amount are composing the measure of the strength of the acid. For example, hydrochloric acid. Somebody now to the place where state the hydrochloric acid and what is the function? No? Well, this is in the digestive system, and the function is for decompose the properties of the food. Okay. For this reason, when you have a stomachache, the concentration of hydrochloric acid change, and you need to drink bicarbonate or water for neutralize this solution. That's okay? Well, acidity can be measured on a scale called pH more scarcely, the negative logarithm of the hydrogen ion concentration. For what reason? When you give a ion in the solution. That's okay? Any questions? Okay, next please. pH, a measure of the hydrogen ion. The scale for the measure hydrogen ion concentration, the hydrogen in any solution must be able to cover a large range. A logarithm scale covers factor of 10. The P in pH stands for log. Next please. This is the table. For example, in the hydrogen ion concentration relative to pH 7, acidic, for example, the battery acid, and the ever, the neutral level is the distilled water, the more pure water. Okay? This is examples. The science battery acid to drain cleaner in alkaline or basic state. Next, please. Well, the pH scale. The pH scale or hydrogen potential is a scale range from 1 to 10 from 14 mole over liters of from 1 to 14. Okay? Ever in the 7 it's the neutral level. In more the 7 from 0 it's the solution more acidic. And the 7 to 14 it's the alkaline and basic solutions. Okay? Next. Well, the pH most living cells have a very narrow range to the tolerance for pH for the change of the interchange, for the hydrogen ions. And the hydrogen concentration will be important either explicitly or implicitly for many other topics in biology. It's controlled in a biological organisms and virtually all biochemical experiments. Each pH unit represents a factor 10 difference in hydrogen. For this reason, the pH is named hydrogen potential, because exists the interchange in ever with the ions for the hydrogen. That's okay? Next, please. Well, how can you actually determine the pH of a solution? What is the importance of the pH? Use a pH meter, read the number, use the pH paper, for example in this picture. Color patterns indicate the pH. Here the solution with precise amounts of base acid in conjunction with a solid dye like a phenolphthalein, whose color changes when a specific pH is reached. This is a proof specific for have a medition of pH when color patterns indicate. It's usual have this experiment in the urine levels, for example, in the clinical laboratory, or the blood, for example. Okay? Next, please. But what's a weak acid? It's a acid with a down level of concentration in the solution. Okay? For example, the vinegar. Next, please. Well, this is the interchange in the down acid, the comparative in the equilibrium, the acetic acid or vinegar, or in the water. Next, please. Next. Well, for our biological system, ionization of a strong acid is too big. In this example, is very short for the picture. Ionization for water itself is a way too little, and ionization of a weak acid is the used in correct balance. Next, please. And finally, why should bicarbonate help? And the bicarbonate is one of the ionization products of carbonic acid. And what is one? Well, by the law of mass action, the addition of a lot of bicarbonate, this is a neutralized solution of hydrochloric acid in your stomach. Okay? Next, please. Well, this is the importance of the pH, control importance of the many enzymes, buffering for neutralize and capability is essential for well-being of organisms, protect the unwelcome change in pH, etc. Okay?
Okay, hi everybody, I am talking about the electrolytes. Next please. Okay, electrolyte is defined as a solvent dissolves in the water to produce a solution capable of conducting current. Electrolytes containing free ions that act as electrical conductors. Okay, the electrolyte is a water, a type of water that containing ions that act as electrical conductors. Okay, next please. Okay, it is possible to distinguish between electrolytes in ionic solution, in molten electrolytes, and solid electrolytes. Okay, according to the arrangement of the ions, the most common are released as electrolyte solutions of salts, acids, or bases. Okay, we have here a pH scale. It's the friend Daniel explained us. Okay, next please. Okay, when in a solution a high percentage of solute dissociate, like in that image, yeah. To form free ions, speaking of the strong electrolytes. However, if most of the solute dissociate faults, reference can be made to weak electrolytes. Okay, you can see that it's a strong electrolyte. Yeah, it's a unit. And in the other image, you can see that it's separate. Okay, next please. Okay. Living things need a delicate balance of electrolytes between the internal environment of the cells and the extracellular environment. The osmosis requires the balance to regulate blood pH, muscle function, and body rotation. The magnesium, sodium, calcium, and potassium are some of the primary ions of electrolytes. Okay, that is one of the contents of the electrolytes. You can see that calcium, potassium, magnesium, sodium. Okay, it is very important you can